Hello, I'm Yuxuan Zhao, and my tag ID is 766. And I picked paper, the clearance constraint PCB global placement with heterogeneous components. And the session title is Adventures in PCB Partitioning and Regulation on June 24th this morning. My research focus is physical design, especially the ASIC placement. Traditionally, the PCB placement is very different from ASIC placement, since the components in PCB can be any shape, and there are very unique design rules, like uh, for the distance between any pair of the two pads with very different shapes, the minimal distance should be larger than a predefined value. So for the PCB placement, the traditional methodology is usually SA, simulated annealing, or a floor plan. But in this paper, they use ASIC, global placement approach. So I'm very interested in how they're doing this work. In my opinion, the core idea is that they find a way to model the density of these anti-shape components in the PCB placement. What they do is they compose the different component shape into a convex shape, so they can easily calculate the overall density values. Besides, they also borrow the classic algorithm from computational geometry field, so they can achieve both high efficiency and high accuracy. What I get inspiration from this work is that actually in ASIC placement, when in the mixed size design, when you rotate the macro, you can certainly encounter the same scenario here. So you can use such similar method to calculate the density value. So which means you can do boost the placement rotation in the global placement for ASIC design. I think this idea and methodology is very useful for my future research. Also, the key drawback of this work, I think, is that they didn't consider the rotation to further optimize the objective, since in the PCB you can have all kinds of rotation of these components. So I think their future work can include considering the rotation for the PCB placement. That's all.